In this episode, I'm going to look at a 1950 RCA Victor Nipper radio. This is an old Bakelite AM set made in 1950. It was made in Montreal, Canada. And this one here is in actually very good condition compared to some of the ones you will find out there. But it does need a total restore. So before we plug this thing in, we're going to do some extensive work on it. Got a couple of old radios in from an old friend to take a look at it and restore for him. This one's an RCA Victor. The model is Nipper, made by RCA Victor in Canada, in Montreal, Quebec. And this one here is an AC/DC radio, so it's going to be an AA5 design. And we're going to open this one up and give it the required restoration, and that includes changing out capacitors and so forth that will need to be changed on this, and of course replacing out this ratty old power cord, which is, well, as you can see, it's seen better days. So we're going to start on this one right now. This one being a Canadian-made radio. We'll use proper Canadian screws, namely a Robertson type. Of course, I grabbed the wrong size. It's a number 1 Robertson, commonly called a green Robertson. So we'll first start by removing the back. As I say, this radio is owned by a very good friend of mine. In fact, he was actually featured in one of my videos a few years ago. This looks like it's dated September 22nd, 1962. Well, that's when somebody wrote that on the inside. That was the date when this was serviced. But this is a classic AA5, so it's going to have the standard 12BA6, 12BE6, 12 AT or AV6, 35W4, and a 50C5 more than likely. There's the 12BE6, 35W4 regulator, or rectifier I should say. Would be this one here. These look to be not all original tubes. This one's an RCA tube. Yep, yeah, 35W4. You guys can't see that, but it is a 35W4. That's probably I'm going to say it's a 50C5, which is what most of these used. Anyway, the tubes are the least of our concerns right now. First things first, let's get the chassis out so that I can actually work on it. I'm going to disconnect the antenna, so I'm just going to unsolder the wires from the actual tuning capacitor and the ground here. That way I can just have this separate so it doesn't get damaged. I should also point out that this is the first video that I'm shooting for 2021. Today is January the 1st. You guys already probably figured that out because I'll be posting this video, I'm sure, today. This wire here is actually a paper-coated copper wire where they spin paper around, so I don't want it to be damaged. Try to keep this thing all 100% original. Okay, first things first, we're going to remove the volume and the tuning knob. These are Bakelite plastic, which means that it's quite brittle, so you have to be kind of careful removing these knobs. And these knobs are actually a must. I'll tell you guys a story here. So we removed the knobs there. I don't know if you guys saw that or not, but we just carefully remove the knobs. These knobs here, this is probably grounded right to the chassis, and it would produce a shock hazard depending on what way the electrical cord is plugged in. Because you see, if I put my meter on and I touch the controls, I have a direct connection to the chassis. Wait a minute, the wire's broken back here. There we go. As you can see, one side of this is actually connected to ground. So these were before they had the polarized plugs. So these were quite dangerous. And if the knob broke, and this is what happened to me when I was a kid. I had a radio like this, very much like this. And the control, one of the knobs was broken, so it was just the shaft that would stick out and that would adjust the volume. And one day I had my arm leaning on an aluminum window sill. I used to keep the radio up on my windowsill just because I got better reception because being in the window. And I was just had my arm leaning on, touching the windowsill, and I touched the knob, and I got the worst shock of my life. It was like sticking my finger in a light socket. And I didn't understand what a hot chassis was before then, and I learned pretty quick what the term hot chassis means. It means that the metal chassis is connected to the knobs, and one of the wires from here is connected directly to that hot chassis. And depending on what way you plug the power cord in, it could either be at neutral or ground potential, or it could be directly connected to the hot phase. Very dangerous design back then, and of course people were being protected by the plastic knobs. If the plastic knob was broken, you became the conductor. When I replace this power cord, I should probably put one on that is polarized, just to prevent that from happening if I have a polarized cord. Again, that's not something that would normally happen because the plastic knobs here are going to protect you from making contact with anything that's hazardous anyway. So I'll pull the chassis out. The whole chassis will lift out here. We'll put the cabinet away for safekeeping. And now we can work on this little gem of a radio. And what we need to do on here is we need to change some capacitors on it. Namely, these ones here. That one there, it's all leaking. But all these paper capacitors really do need to be changed out. This one may need to be changed. It's a dual 40 microfarad 150 volt. This is the main B plus capacitor. It may need to be changed. It may not, but for sure these paper condensers have got to go. Because if they're not replaced, what is going to happen is they become electrically leaky. I'm not going to go into electrically leaky capacitors in this video into much detail because I've covered that before. If you look at some of my other vintage radio repairs, we've talked about what happens on these capacitors. But basically what the job of the capacitor is doing in many cases, they're used for two purposes, and filtering is not one of them. That's typically done by the main electrolytic capacitor. But what these capacitors are being used for is they're being used to couple one stage to the next and block DC. So they'll be connected to the plate of one stage and then going to the grid of the next stage. And their job is to allow the AC signal to pass through the capacitor while blocking the high voltage DC from getting into the next stage. Because if any of that DC voltage were to get into the next stage, what it's going to cause is it's going to cause the tube to become biased and will cause the tube to go into conduction higher than it's supposed to go into, and that will ultimately shorten the life of the tube and or shorten the life of other components that the tube is being fed into, such as audio output transformers and IF coils and stuff. So very important to change those capacitors out, and we'll change out the power cord on this while we are at it. This one's using a dynamic speaker. Some of these old radios used an electromagnetic speaker, which actually had a coil of wire, and they put the B plus through the coil to generate the magnetic field for the speaker. But those were the very early ones. This one's a dynamic speaker. Here's our speaker wires here going down, and you'll see that they go down to this transformer. So this one here is the audio output transformer. The primary of that transformer is going over here to the audio, to the output tube. I guess it is this one here. Going over to this tube here, the output tube. This is the rectifier tube on this one. So first things first, let's start changing these ugly capacitors. And I have some here. I should have ones that are close enough to replace these. So this first capacitor I'm going to change. It's rated at 0.05 microfarads, which is an oddball size. I've got a 0.047. This one's 150 working volts. This one's 630, so more than enough. And this has been covered before. I've covered it before. Others have covered it before as well. But on these type of capacitors, there's what's called the outside foil, which goes to your low impedance side. And basically what it is the capacitor itself is just two strips of coil that are two strips of foil separated by a paper insulator that's got an electrolytic on them, and they're wound up in a tight coil. And the outside foil is the one that's on the outside that provides some shielding to the inside foil. These ones were always marked. We usually like a band on it to mark the outside. The newer capacitors are not marked. There's a way to do it. I've shown it in other videos. You use an oscilloscope and just measure the amount of signal that it's going to be picked up. The side, when you put your scope, you put your ground on one side and your probe on the other. And as you move your hand near the capacitor, you'll get a stronger signal when the probe is connected to the outside shield or the outside foil than when it's connected to one of the inside foils. I've already pre-marked these. Like I put a little line on them, so whenever I go and buy new capacitors, the first thing I do is I get the scope out and sit down and check them all to make sure that they're all correctly marked, so that I know when I'm installing them that I'm installing them in the correct orientation. They're not polarized, so it's not negative, as in a negative polarity like you'd find on an electrolytic capacitor, such as this one here that's marked negative black. This is just to indicate the outside foil. These are non-polarized capacitors, but there is a foil plate on the outside that's wrapped, and that is the side that you want to connect to ground or connect to the low impedance side of the circuit. So for example, going to the plate, it would go to the plate side, and the inside foil would go to the grid of the next stage, because that's the high impedance side. It's going to the grid of the next stage. So the easiest way to take these out is just to cut them and then solder onto the terminal. So I'm going to cut this one off here, and I'll solder the side that is the inside foil to here. If I can find my roll of solder. The other side of this one went down to this transformer down here, so we're going to clip that side off. I'm going to use the insulator that was on the original one to insulate the wire, so that I don't have to worry about it touching anything else that it's not supposed to be connected to. And that's why they had the insulator on the original capacitor, just like that. I'll put the insulator on here and take this one down and connect it to its appropriate lug here on this transformer. I'm going to bend it around. And solder it in place. Now, one thing when you're working with a soldering iron around any of these coils. You gotta be careful not to touch any coils like this because they're just coated with wax, and you could easily damage the wire that's under them. So you gotta be careful when you're working around these things here. Also be careful of the fine wires that are around here. As you can see, there's a wire there and there's another one there. So these ones are unobtainable if you were to damage them. So if you're working in these, be careful getting around with the iron around any of these delicate coils for a radio like this. Next one I'm going to change out is this one here. This one's on the power switch. This is a bypass capacitor, this one. Looks like somebody's been cutting wires on here before. That wire's been cut. Looks like somebody's replaced a wire in here. We'll just take that extra little tab off there. There's no point in having that sticking out there, waiting to short against something. To say this radio belongs to a good friend of mine that I've known since known him since high school. And he was actually featured in my video I did when I went up to Quesnel to visit him at the first radio station he worked at. He spent his career in radio. He's now left the broadcasting industry, but he was in the broadcast industry for many, many years, right out of college, basically, up until recently. He was on one of the big radio stations here in the Lower Mainland market. And he's a ham radio operator as well, and a radio collector. And he picked this one up. I think he said he got it off Facebook. He actually got two of them. So we're going to be restoring both of these radios so that he can put them back into service in his collection. It's always nice to help out a fellow collector of old vintage radios. This one here, we look at this one here. This one here was British made. Okay, it's a 0.1 microfarad, 500 volts. Got lots of those. This one here, the outside foil is to this one here, of all places. I think that was the outside foil. Yeah, outside foil is right to that one. So we'll find 0.1. I'm sure I've got one of those here. So there's not too many that I really have to replace on this. There's basically 5. Right, even this one here, I'll probably replace this one, the Black Beauty. These ones tend to go bad, so it's like 6. So 0.1 microfarad. Let me find one of those. So then it's a 0.1. We'll get this one installed. Hook the ground side up first. And this is the power cord I'm going to be changing out. One side of the power cord goes to the switch there. So we'll be changing that one out momentarily. In fact, this is probably the cap that was leaky that was causing me to get connection to the chassis on the power cord. When I was measuring between the knob and the power cord at the back here, I was getting like a resistance. It was very likely this capacitor here has shorted internally, because that's the one whose job is actually to try to isolate the AC line from the radio itself, from the chassis. And when that one fails, you end up losing your isolation, which is a bad thing. .01 is the next one. It's just on the volume control. That'll be a coupling capacitor that'll couple the audio in. And that one's been changed before too. You can see that someone just cut the wire and just soldered it on to the existing wire. So that one was swapped out in the past. I guess it doesn't want to sit the other way, does it? And this next little condenser here, or capacitor, is a coupling cap, interstage coupling cap. We'll just clip it out of the circuit and find another one for it. There's one side of it there, and the other side of it is in behind this speaker lead. This one is a 0.005. So I should have like a 0.0047 in here somewhere that'll be close enough. So one wire is down here that I gotta solder onto. And the other side goes to this one here that's got this insulator on it. We'll take that back a bit. Again. The reason why they've got this insulator on there is because it passes right over top of another connection on the tube socket. So they slide that little tube of insulation over there just to prevent any short circuits. So we'll put that in right where that is, and then just loop the wires together here, twist them together and solder them. Like that. one more left, one more critical capacitor that has to be replaced is this one here that's spilling its guts. It's a 0.1. The outside shield goes to this side over here. It's a 0.1. I think it's a 0.1. 0.1 microfarad. Yes, 0.1. Let's find a 0.1 to change that leaking one. It's most certainly shot. Okay, that's got all the capacitors changed. We're going to change out this port skews for an AC cord and put something a little bit more modern. Safety first, right? So let me go find a cord. We'll get that cord replaced, and then we can actually try this radio out and see if it works. Love it how they just tied a knot in the end of it. Look at how brittle this was, the old insulation just coming off the cord. I've got a replacement one here that will do the job just fine. A little heavier than the original one. We'll feed it through the original grommet. So this is the original power connection up here to the switch. We'll just take the old wire out and bring the new wire, follow the same route that the original one went. Bring it up from behind. And connect it to the switch. The other side will connect down to the 35W4 tube, the socket down here. to get that grommet back in. The rubber grommet is kind of deteriorated on the back here, so we're going to get that back in there just to strain relief for the cable. Okay, this little radio is ready to power up for the first time. So we'll turn on the switch and see if any tubes light up. Tubes are all in series on this, so they should all start to glow. And if they don't, then we have a tube that's probably open. And, I hear some sound. I hear something. Antenna. Okay, let's put an antenna on this thing. We know that we got some sound. I don't hear anything yet, but then again, I haven't reattached the antenna, so let's reattach the antenna to it first. We can do that before putting the unit back into the cabinet. And then see if it will receive any signals. There's my test transmitter. I would say this is a success. Bloomberg radio should be the next one down. Where am I going here? Success! Let's reinstall the radio back in the cabinet, get it put back together, and get it ready to send on out. Let's just see what stations I can pick up locally on this thing.
Way blocked off to eastbound traffic until later this year. That will go until February.
Distancing can be promoted in classrooms. Is, still very concerning to us that Surrey School District alone.
I got so much noise.
8 for Tuesday. For Abbotsford, 9 for the airport. Downtown at 7. Weather's for Drainmaster. Drainmaster is your trencils expert, specializing in water lines, sewer lines, and drain tile repairs without digging a trench. Visit DrainmasterTrenchless.com.
When you can't listen to traffic on the radio, get your updates on Twitter. Follow us. We're at News 1130 Traffic.
News 1130 Insider Exclusive.
This month,
That's the station my buddy that owns this radio used to work for.
to get to Reza Sachi Jewelry. Reza Sachi.
Our government has facilitated.
Kenny has now ordered all cabinet ministers and senior government officials not to travel outside Canada unless it's for government business. Calgary Police.
Okay, I'm going to put this thing together, and I'm satisfied that it's working. It's picking up the local stations, no problem. So this one is one for the repaired category, and restored at that, because you know, when you've got these old tube radios, you have to change those capacitors. That is a must. If you don't change those capacitors out, you're going to burn tubes out, you're going to burn out transformers, you're going to burn out coils, and you're never going to get those parts for a radio like this. This is marked 1962. That was probably when this thing was repaired last. And so it's a lot older than that. I don't know the exact age of this radio, but it's old. It's a fair bit older than I am. I would say this is probably, you know, maybe early 50s. Early 50s style. Should I tag this? I mean, the last guy that tagged it put the date on it. I think I'll tag this too. I'll get my magic marker out, and we'll put a little notation on the inside of the chassis. Note the notes on the back of this. Well, first there's the disconnect power cord from outlet before removing chassis from cabinet. No kidding. 105 to 120 volts, or 125 volts, AC, DC, 0.3 amps. This radio is made to operate from any 110 volt source, 25 to 60 cycles, or DC power source. If the set fails to operate on DC, reverse the power cord plug at the outlet. Because if you're plugged in one direction, you won't get any B+. So you turn the cord around when you're running from a DC source. On an AC source, it doesn't matter. So there it is. It's back together. Let's put the knobs back on here and do one final test.
Respect.
Here's what's making news right now.
As another Canadian politician is caught leaving the country despite public health recommendations.
Bounce to the right side. That'll leave 16 ticks of this Rose Bowl game. Sometimes you inside the pocket.
Continued to work while on holiday, but he learned of her trip on Tuesday and he asked her to return.
I was not aware of any MLAs or ministers traveling abroad until this week, and
Motorway times are estimates and they're always changing. As of right now, they're still shut down in both directions unless you're a commercial vehicle, in which case you're getting through in about 10 minutes in each direction. Motorway times estimates, and they are always changing. And remember that...
Hi, I'm Gina. I'm a former flight attendant.
For over 30 years, Brian Jessel set out to earn your trust and respect. To do so, Brian put your needs...
5353.alyoung.ca. Again, that's alyoung at...
Thanks for watching, guys. We'll catch you in the next one real soon. Bye for now.